Hi, my name is Ginny de Villiers, and I will be doing the lectures on integration and then on statistics. Okay, so this presentation now, part one, is simple integration. In other words, if we have a 6x squared minus 10x, what do? Is we add 1, and that's what we divide by the 6 by. And the 10x, we add 1, so we're dividing 10 by 2, and that's what we get. Okay, so I'm not going to spend much time on it. You need to practice it. Please don't forget your plus C. You don't want to lose a mark there. Okay, so what I want to start with is just simple reading from your table, just trig integration when you've got single angles. Okay, so the idea is off the table here, if I ask you for the integral of cos x, you would look at the table and go, okay, cool, my antiderivative is the opposite of my derivative, so therefore I'm looking at sine x plus c. All right, no matter what I get, if I get sec x times by tan x, I have a look at the table, and my answer is simply sec x plus c. Likewise, if I have sec squared x dx, integral would be tan x plus c, and cosec squared x would be minus cot x plus c. So quite simple, just reading off the table. What have I got? Single angles, single angles, single angles, and so on. Okay. So the straightforward examples here are a few. If you can see a quicker way, then feel free to do it. But bottom line is, most of the time, you're going to multiply this out or split the function and so on, and get it out. I'm not going to go through these with you, but here are the solutions if you want to get some practice in doing that. Okay, we'll just chat quickly about the trig ones. So here we've got 3 sine x plus 1, the integral of. So I want to look at my table. And I'm going to look at the table and go, okay, cool. The sine, so the sine x is obviously going to be negative cos the 3 doesn't bother me. The 3 is part of my solution. So my solution is minus 3 cos x plus c. Okay. For this one, I look and I see cosec x times cot x. When you've got two trig things like that multiplied together, a lot of the time it's going to be the table. So cosec x cot x, and I add to 2, so it's going to be negative 2 cosec x plus c. And here I've got just 2 functions added together. So that's going to be a quarter x to the 4 plus, I'd have a look, sec squared x, and I've got 2 tan x plus c. So it's nice and simple. You want to get these questions right. Okay. Right, now we're going to look at using inspection if the composite function is linear. Okay, so this is sort of a new topic for some of you. But the idea is, let's say I get a power function. All right, now if I have a power function, I don't want to multiply this out. If I've got a power function, what I want you to look for is to see whether this inside the bracket is linear. In other words, ax plus b or mx plus c, all right? And if it's linear, the idea is we want to follow a rule, and this works really well. All right, so what the rule is that I'm going to go 1 over the derivative of the linear thing. Okay, so that 3 and that 3, which is my derivative, I'm going to go 1 over the derivative times by, and this 5 is my from there. So it's 1 more from my index or my power that we're dealing with. And this works every single time. So that would be 1 over 3 times 1 over 5, which is 3x minus 2 to the 5. All right, so let's have a look at some examples. So the examples would be here. Is this linear? Yes. So I would go 1 over minus 1 times by 1 more than that, which is minus 1, times by 5 minus x to the minus 1 plus c. So these actually all cancel each other out, and I'm left with 5 minus x to the minus 1 plus c. All right, let's do another one. So if I have something like this, 2, I look and I see, oh, good, that's linear. So if I bring it up, I get 2 times 3 minus 5x to the minus a half dx. Okay, it's linear, so I'm going to go equals 2 over minus 5 times by 1 more than minus a half, which is a half. And if I clean that up, I'm going to end up with minus 4 over 5. 3 minus 5x to the half. Try a couple. They really are quite easy. So the general rule would be, if I have a linear function, it's going to be 1 over a times by 1 more than that. And I would continue the integral of the bracket. Okay, it is really worth it. It saves a lot of time just to be able to do it by inspection. Okay. All right, so let's look at a similar concept, and that is if the trig angles are linear. All right, so if the trig angles are linear, we've got cos 2x dx. All right, so the angle is linear. So actually, all we're going to do is I'm going to, well, here's my table again. All right, so what I'm going to do is I'm going to go 1 over the derivative of that, which is my 2, and then I'm going to change this to what it is, the sine 2x. Okay, so where does that 2 come from? Is that 2 over there, and this angle is always going to be exactly the same as this angle over there. So let's try another one. Cosec squared 3x dx. Now this all happens when I've got the table over here. So cosec squared 3x, so that's going to be now a third or minus a third because cosec squared is minus cot. So minus cot 3x plus c. Okay, the third example is I've got the 2x and the 2x, so that's sec 2x tan 2x, so that's no issue. So I'm dividing by my derivative, which is 2. So this should be 3 over 2 sec 2x. 3 over the derivative of my angle, sec 2x, same angle, plus c. Quite easy, all right? This is also linear, so it might look like it's complicated, but that is still linear, so it's 2x plus 1. So this should be, the integral of minus sine is cos, so this should be 1 over 2 cos, whatever that angle is, plus c. Okay. Okay, then I thought I'd give you this one, which is not easy at all. The idea is when we've got squares, or we've got something, we're not really a fan. We don't mind. What I want you to be realize is we don't really mind big angles, because if this was, let's say, the cos of 6x, it would simply be 1 over 6 sine 6x. So we don't mind a double angle or a triple angle. What we don't really like is something that's not on the table. All right. So the sine squared is not on the table. But if we look closely at this, can you see that this is actually a double angle formula? All right, so it's 1 minus 2 sine squared theta, which is a double angle formula. So that actually can change to the cos of 6x. All right, and the cos of 6x is actually great because I've got a linear function. So it's 1 over 6 sine 6x plus c. Okay, so the same applies to the exponential and the hyperbolic functions, right? So let's have a look. If we've got e to the 2x, we can see that that is linear. So what do? I simply go 1 over the derivative e to the 2x plus c. As easy as that, all right? This is linear, so I'm going to go 1 over negative 3 e to the 2 minus 3x plus c. Done. This one, I would have to do a bit of work. So obviously, when I'm multiplying exponents, when the same base, if I've got the same base, I add the exponents. So this is going to be 6e to the 3 plus 2x. What is my derivative of the linear is 2, so it's 6 over 2 e to the 3 plus 2x, which can be simplified to that. When it comes to the hyperbolic function, remember that the derivative is with the integral, we're dealing with ln, the natural log, but here it's a linear function over there. So what do? I find the derivative of it, so it's going to be a half, or 1 over 2 ln and mod 2x minus 1, or absolute value of 2x minus 1 plus c. Okay, so if there was a value over there, it doesn't matter. This would now be 3 over minus 5 ln 2 minus 5x plus c. Okay, so it is really worth looking for that linear function with every single one of the things because you can immediately do it by inspection. Please practice it because it is going to save you a lot of time. Thank you.